Okay, so this is going to be the worked out solution to 2019 2C part 4. Written out our equation, and from our 6 steps, the first thing we do is we write out our ratio, which in this instance is 1:1. We then look at the info from the question. So I have 2.9 centimeters cubed of ethanol. I have a density of 0.8 grams per centimeter to -3. I have, for my ethene, I have a 26% yield. And I'm looking to work out volume at RTP. So this is the kick in this question. This is not our usual way of going through it, and you need to recognize that when the time comes. So we're going to start on the left-hand side because this is the way in. So I have here centimeters cubed, but there is no mention with that centimeters cubed of RTP and STP. And I understand that it is over here on this right-hand side, and we'll deal with that then. But this particular volume on the left-hand side, there is no mention of these. So we cannot use the volume triangle. We do have a density. So at this point, I'm hoping that you're recognizing that this is the triangle that we have to use. So we are going 0.8 grams per centimeter cubed multiplied by 2.9. And when I do that, I am getting 2.32 grams. I have grams, so it means mass triangle. So I need to find my molar mass of C2H5OH. So that is 12 by 2, that is 1 by 5, that is 16 and 1. When I add all these up together, it's going to give me 46. So 2.32 divided by 46 is going to give me 0.0504 moles. At this point, we rewrite our ratio before we finish anything else. And as it's a 1:1:1, then that's very straightforward. Okay, and for anything that's left, we are using that whatever's inside in this box. So we're interested in the ethane, and usually we would be multiplying this by a molar mass to find a mass, which would be our theoretical yield. But our question has asked us volume at RTP. So you have to recognize that this is going to be a different triangle. So the triangle that I am looking for is going to be volume at RTP. So my molar volume at RTP, I'm going to multiply this. It says volume, we'll keep it in centimeters cubed. So it's going to be multiplied by 24,000 centimeters cubed. Okay, that was the kick. So once I've worked that out, when I do that, I am going to get somewhere around the region of 1,200 centimeters cubed of ethene. Okay, so you need to recognize that this is a theoretical yield. And our percentage yield formula is actual over theoretical by 100/1. So we fill in what we have, because we do have lots of pieces of information. So what we have is we have a percentage yield of 26. We know that 26 is equal to an actual yield, which we don't know. Our theoretical yield was around 1,200 centimeters cubed, multiplied by 100/1. And now we're doing a little bit of algebra in that we are going to move everything such that all I have left is actual on this side. So to get rid of the 1,200, I have to multiply both sides by 1,200. To get rid of this 100, I need to divide both sides by 100, because these will all cancel out. And when I plug that into my calculator, I should end up getting an actual yield of somewhere between 300 to 315 centimeters cubed. So there was 2 kicks in this, in that over here it needed to be your volume triangle that you were using, and over here, we were rearranging our percentage yield formula when it's filled in so that we were solving for actual.